Hi, my name is Braxton Hatfield.
And I'm Devin Jude, and this is our PowerPoint presentation of our VEX Robotics and Principles of Engineering curriculum. We are currently sophomores at Belfry High School in Dr. Haridas Chandran's engineering program. Principles of Engineering curriculum. This project has supported a wide variety of careers in engineering and technology and covered various technology systems and manufacturing processes. This project helped us to get a better understanding and hopefully help us out in the future to be able to solve first-hand problems if we decide to go to the route of the engineering field, and ultimately help us to be better engineers and better students. This project focused on many different things, and especially we had to understand the scopes and the sequences of the course, energy and power, materials and structure, the control systems, and the statistics and kinematics to make the robot work properly and to understand how to properly use it. Understanding the concept of machine control system in the engineering curriculum. To carry out activities in this unit, VEX Code VR was used, and in order to use this, we had to have a grasp of the concepts of engineering and outputs, basic output programming, while loops and if-else structures, and variables and functions, and this helped with the coding of the robot. Here's an example.
With VEX Code VR, you can program a VR robot to do many things. Every project begins with a when started block. There are many different blocks that you can use to program your robot. Let's add a few blocks to our project. Blocks can easily be stacked together, rearranged, and deleted.
Now, I won't let the whole video play, but that is how we use the codes for the robot. During virtual learning, we created a program to implement an algorithm focusing on using a pen to draw a square by moving 500 millimeters forward and making a square by the robot using VEX Code VR program. And here's another short video that I will show you the codes. These are codes that we personally made. To have a hands-on experience with the VEX V5 robot, we had to understand the concept of control systems also. In order for this, we had to not only know where to place, but also know how to use all the different parts of the bed device. So we had to know what the motors were, the limit switch, the potentiometer, and the bumper switch, and what they done. Some more parts we had to know about were the optical sensors, the distance sensor, the LED, and the servo. All the tested systems were ultimately put together, and we wrote programs that made a testbed device that would do certain things, and which can be used as a model for next year and future robots that we may build. Experiences gained from the testbed device gave us confidence to build a winding device, or as many people know, as a winch. During each stage of building, we learned and used simple machine techniques, which not only let us know how to build the winch, but to make it more visually appealing and how to make it better. The final build of the robot had a dimension of 15 inches by 7.75 inches by 12.5 inches. And it pulled a load of 1.4 pounds, as you can see in the picture right here, which is actually a video I will show you. The two pulleys and the limit switch ultimately made the robot better because the two pulleys would make it stronger to where it could pull more weight and be more steady, and the limit switch made it to where we can stop it and start it when we want. Here's an example of the winch. As you can see, when the truck backed up, it hit the limit switch and it stopped on its own. After we saw how easy it pulled the 1.4 pound truck, we decided to test it a little bit further. So we went to our weight training facility and got a 5 pound plate, and when we tested it, we were actually surprised at the result. It pulled the 5 pound plate pretty easily, as you can see. The budget detail for this project, as you can see on the right here, as the certain amount of money allotted for the VEX V5 Classroom Starter Kit, the Foundation Add-on Kit from VEX Robotics, and the Completion Add-on Kit. We were very successful to use the VEX V5 robot for the Principles of Engineering curriculum provided by PLTW. Now, obviously, we are very thankful to everyone that has helped us in this, and we would specifically like to acknowledge your administration for providing us with the use of the STEAM Lab to carry out all the hands-on activities, as the STEAM Lab really has everything we need, and it's great. We would also like to acknowledge KVEC for providing us with the Learning Innovation Grant for $1,000 to successfully complete this project. And a lot of people doesn't realize grants like this and projects like this really make school fun, and it makes it to where kids can look forward to coming to school. And personally, I know I did, and we're just very thankful for this learning experience.